universe is exactly 13.8 billion years old. Because nothing can travel faster than light, the cosmos operates on a strict absolute speed limit. If we trace a beam of ancient light moving through space for that entire 13.8 billion year lifespan, the absolute furthest edge of the cosmos we can see should sit exactly 13.8 billion light-years away from Earth. Mapping that logic out in every direction creates an observable universe with a maximum logical diameter of 27.6 billion light-years. Yet modern astronomy proves the actual diameter of our observable universe is a staggering 93 billion light-years. Crossing 93 billion light-years in only 13.8 billion years reveals that space functions as a dynamic physical medium rather than a fixed, empty container. For centuries, astronomers viewed the night sky as a static, immovable stage. That perspective changed in the 1920s when new observations revealed a hidden motion among the stars. Physicist Georges Lemaitre and astronomer Edwin Hubble measured the light from distant galaxies and discovered that they are actively moving away from Earth. When they compared the distance of those galaxies against their speeds, a mathematical pattern emerged. The further away a galaxy sits, the faster its rate of recession. Galaxies remain relatively still while the physical fabric of space between them stretches, wedging the objects apart. Resolving the 93 billion light-year paradox requires treating empty space as a tangible, stretching fabric. Rewind the clock 13.8 billion years. All matter, energy, and space were compressed into a single, intense, blinding point. This singularity contained the entirety of space, with no external void to expand into. In a fraction of a second, the universe underwent cosmic inflation, an event where space expanded exponentially, doubling in size dozens of times. We can still see the evidence. This heat map of the cosmic microwave background captures fossilized quantum fluctuations from the early universe. These microscopic temperature variations were frozen directly into the fabric of space. Over billions of years, gravity pulled matter into these dense regions, forming the first stars. The Big Bang describes the initiation of an everywhere stretch, the sudden expansion of space itself that continues to this day. As the violent inflationary period ended, the universe cooled, allowing raw energy to condense into particles, atoms, and eventually the first stars. When one of those early stars released a photon of light, it began its journey across the cosmos towards Earth. While that photon moved forward at the speed of light, the physical space traversed simultaneously stretched beneath it, adding distance like a runner on a moving treadmill. By the time that light hits our telescopes 13.8 billion years later, the continuous stretching has created a massive co-moving distance. The 93 billion light-year diameter serves as a fossil record, documenting how space has continuously stretched for 13.8 billion years. Modern measurements show that the speed of this cosmic expansion has shifted throughout history. For billions of years, the gravitational pull of all matter in the cosmos acted as a brake, successfully slowing down the universe's expansion. Roughly 7.5 billion years ago, the universe changed gears and the expansion began to accelerate. This shift is driven by dark energy, a mysterious repulsive force making up 70% of the universe that is now actively outpowering gravity. An unseen energy is currently tearing our universe outward at an ever-accelerating rate. Projecting this accelerated stretching forward reveals the ultimate consequences for our observable night sky. This accelerating expansion creates a future horizon, a cosmic boundary where space is moving away from us faster than the speed of light. Distant galaxies will eventually drift across this horizon, leaving their light forever unable to reach Earth. This leads to the Big Freeze, a scenario where the universe becomes a dark, cold, and unimaginably stretched out void. The Big Bang remains an active, inescapable process that continues to define the physical fate of everything we see.